You ever stopped and wonder what kind of magic makes your favorite apps just work? Well, today we're going to pull back the curtain on the incredibly powerful tech that runs pretty much the entire modern internet. But we're also going to explore the hidden trade-offs that come with all that power. This is the cloud-native paradox.
All right, let me ask you something. Just think about the apps you probably use every single day. What do Netflix, Uber, and Spotify all have in common? I mean, beyond being on your phone's home screen. What's that one invisible thread connecting them all?
Well, the answer, the secret sauce really, is that they're all built on what's called a cloud-native architecture. It's this fundamental design philosophy that lets these huge companies serve literally millions of people all at the same time without breaking a sweat. It's what makes them so efficient and so reliable.
Okay, I know what you're thinking. Cloud native. It sounds like just another tech buzzword, right? But it's actually a really big deal. It represents a massive shift in how software is even built and run these days. So let's really break down what it means.
So at its heart, a cloud-native app isn't just something that, runs in the cloud. No, it's designed from the ground up to thrive because of the cloud. Think of it like this. Instead of one giant block of code, it's built from dozens or even hundreds of tiny independent pieces called microservices. And each of those is packed into its own little self-contained box called a container. This whole modular setup, that's the secret. That's what gives these apps their incredible power to scale and bounce back from problems. And listen, this isn't some abstract tech nerd concept. We are talking about the very backbone of your daily digital life. Every single time you scroll through Instagram, book an Airbnb, or post on X, you are using a cloud-native system. These are the companies that have mastered this stuff.
All right, so why is every company on the planet scrambling to do this? What is this incredible promise that makes cloud native seem like the holy grail for building software today? First up, and this is the big one, unlimited scalability, or what the pros call elastic scalability. Just imagine this. Your company runs a Super Bowl ad. Boom, 1 million new users flood your app all at once. An old school system, it would just fall over and die. But a cloud native system, it just expands instantly. It meets that massive demand, and then, when the rush is over, it shrinks right back down. It's incredible.
Next up, ultimate flexibility. So these apps aren't chained to one specific cloud company like an Amazon or a Google. Remember those little containers we talked about? Well, because the software is packaged up like that, you can basically pick it up and move it anywhere. This gives companies a ton of freedom and prevents them from getting stuck with one super expensive provider. No vendor lock-in.
And then there's reliability. Now, this is going to sound a little weird, but cloud-native apps are actually built to fail. What does that even mean? It means if one tiny piece of the application breaks, the rest of the system just keeps on chugging. It doesn't bring the whole thing down. It's designed to be fault-tolerant, and that's exactly why services like Netflix almost never seem to go down. I mean, the list of benefits just goes on and on. You get super high performance, 24/7 availability. You can push out new updates super easily. Plus, it's all built on amazing open source tech like Docker and Kubernetes that handle all the packaging and management. I mean, it sounds perfect, right? Like a totally flawless solution for everything.
So, what's the catch? Because you just know with this much power, there's always a catch.
And this right here is the paradox. All that incredible power, all that flexibility, it isn't free. You pay for it with a currency that's not always obvious at first. Sheer, mind-bending complexity. And we're not talking about some vague idea. This complexity creates very real burdens, technical, operational, you name it, that can absolutely crush a team that isn't ready for it.
So let's dig into what those burdens actually look like.
Okay, so to really get it, you have to understand the before and after. We used to build software as a monolith. That's just one giant unified chunk of code. Super simple to get started with, but an absolute nightmare to update or scale. Now we have microservices. They're amazing for scaling, but instead of one big thing, you're now juggling hundreds of tiny independent services and all of their crazy complex interactions.
So what does all this complexity actually feel like in the real world? Well, it means that one single click from you, just one tap on your screen, can set off a massive, invisible chain reaction. Let's stick with the Netflix example. You tap play on a movie. In the blink of an eye, here's what happens. Your request hits an authentication service to see who you are. Then it zips over to a billing service to make sure your subscription is active. Then another service grabs the movie's title and poster. Another one handles the security to unlock the stream.
All of that has to happen in a split second. And if just one of those little services hiccups or slows down, your movie night is ruined.
So you can see how this creates massive technical headaches. Your engineers are now managing this insane spider web of connections between services. They have to write tons of extra code just to handle what happens when one part fails. And trying to find a bug? Oh man, it becomes a full-on detective story where you're hunting for clues across dozens of different systems. It's a huge time sink.
And this isn't just a coding problem, it's a business problem. Operationally, this is a heavy, heavy lift. It costs a fortune to run all that cloud infrastructure. You need to hire engineers with very specific, very expensive skills. And just testing your app becomes a nightmare. How do you possibly replicate that massive, complex system on a developer's laptop? You can't. Not really.
And all of this leads to the single biggest risk of them all, over-engineering. It's when you adopt all this insane complexity before you actually need it. The classic example is building a skyscraper for a lemonade stand. It's powerful, sure, but it's also wildly unnecessary and will probably bankrupt you.
So after all that, what's the verdict? Is cloud native just bad? No, not at all. The real point here is to see it for what it is, an incredibly powerful tool, but for a very specific set of problems. It's all about finding the right balance.
There's a great line that really hits the nail on the head here. Sometimes a much simpler architecture can give you basically the same results, but with way, way less complexity. You don't always need to bring out the heavy machinery for every single job. Simpler can often be better, cheaper, and faster.
Look, at the end of the day, cloud native is a massive, powerful hammer. But not every problem is a nail. The real secret to success in tech isn't just chasing the latest, hottest trend. It's about taking a hard look at your actual business needs and then picking the right tool, simple or complex, for that specific job.
And that kind of leaves us with one last big question to think about, right? This whole paradox, it's not just about software. You see it everywhere. We're constantly being sold more and more complex solutions to our problems. So it's worth taking a step back and asking, is more complex really always better?